In this question, the open loop transfer function of a unity feedback system is given. Now we need to determine the condition of stability with respect to the parameter t, which means we need to determine for what values of t this system is stable. Okay. Now first, in order to determine the stability, anyway we will be using the Routh-Hurwitz, for which we need to know what is the characteristic equation, and for that we need to determine what is the closed loop transfer function, or in fact we can directly determine the characteristic equation also, which in this case would be, so since it's a unity negative feedback system, so the characteristic equation just follows like 1 plus g is equal to 0 plus g of s. Okay, because this is what we get in the denominator. So that for this system is s into s plus 1 into s plus t plus 42 is equal to 0. Okay, now from this we will get s cube plus s square into 1 plus t plus t into s, so st plus 42 is equal to 0. Now this is the characteristic equation. Now we will have to construct the Routh array. Okay, so it will first row is s cube followed by s square. Okay, for s cube we will get 1 and then t, and for s square we will get 1 plus t and 42. For s power 1 we will get t into 1 plus t minus 42 divided by 1 plus t. So it's 1 plus t into t minus 42 into 1 divided by 1 plus t. For s power 0 we will get 42. Now in order to establish that this system is stable, we have to make sure that this all the values in the first column are of the same sign. Okay, now we have 42 and 1 here which are positive, which means all the values in this first column have to be positive. So from the second row we will get 1 plus t is greater than 0, this condition for stability, which means t should be greater than minus 1. So that is one condition, and let us see what is the condition that we will get from the third row. Okay, here we have t into 1 plus t minus 42 by 1 plus t is greater than 0. Okay, we very well know that 1 plus t is greater than 0 because that is the condition we have from the second row. So I can safely say this particular value is greater than 0 if t into 1 plus t minus 42 is greater than 0, or t into 1 plus t is greater than 42, which means we know 6 into 7 is 42. So t should be greater than 6. Okay, so we have two conditions, t has to be greater than minus 1, t greater than 6. So we need to obviously choose t greater than 6. Only then both the conditions are satisfied, because if I take the first condition to be the condition for stability, it is not satisfied, it does not satisfy the second condition. So the condition for stability here is t should be greater than 6. So the correct option is D.